For this video lesson on the mole and molar mass, you are going to want to have your periodic table and a calculator. So where does this number 6.02 times 10 to the 23 come from? Well, one atomic mass unit of matter is equal to the mass of one proton, or essentially the mass of one neutron. If we figure out what this mass is in grams, right, one atomic mass unit is a very small amount of mass. It's 1.67 times 10 to the negative 24 grams, right? So this right here is an equality. And when we have equalities, we can use these in conversion fractions. So we're going to use this as an equality in to convert the mass of one carbon into grams, right? So carbon, as we know, weighs 12.0 AMUs. To find its mass in grams, we start with a fraction. One atom of carbon weighs 12.0 AMU. Okay. So if we then put in this fraction where we put AMUs in the denominator, and so 1 AMU is equal to 1.67 times 10 to the negative 24 grams, and then we multiply across and divide by the bottom, right? AMUs are going to cancel, and the math just becomes 12 times 1.67 times 10 to the negative 24, and the units left over are going to be grams per atom. So let's put that in the calculator. We're going to have 12 times 1.67 to the negative 24, and we get 2., we got 3 sig figs, 2.00 times 10 to the negative 23 grams per atom. Okay. Well, we have yet another equality where essentially and this is of course for carbon, very specific to carbon. One atom of carbon will weigh this mass. Okay, so this is the mass of one atom, but what if you didn't have one atom? Let's say you had 6.02 times 10 to the 23 atoms of carbon. So let's put that in here, 6.02 times 10 to the 23 atoms of carbon, right? And we now know that one atom of carbon has a mass of 2.00 times 10 to the negative 23 grams. So atoms will cancel. And then we have this number, we have 2.00 exponent times 10 to the negative 23, multiplying that by 6.02 times 10 to the positive 23, and we are going to get 12.04 grams of carbon. Now, so interestingly enough, you might say, well, that doesn't match that number, but what you have to realize is that we are actually using fairly rounded numbers in this, but it does certainly give you the approximation of what's going on. Okay, so bottom line, if you take the atomic mass from the periodic table and you weigh out that number in grams on an, this is supposed to say electronic or digital scale, electronic balance, you will have 6.02 times 10 to the 23 particles. In this case, those particles were specifically atoms, and we say that that is 1 mole of particles, because saying 6.02 times 10 to the 23 becomes a bit cumbersome, and 1 mole is just a convenient way to describe it. Okay. This number, this concept of weighing out that number in grams, right, this is what is called molar mass. Right, and so the mass of 1 mole of carbon atoms is equal to 12.0 to 3 sig figs, 12.0 grams. The mass of 1 mole of carbon weighs 12.0 grams. So the mass of 1 mole is what we refer to as the molar mass. Okay. So let's try this, right? Right, so we know, let's kind of revisit this. This is not anything new right here at the top. Molar mass is the mass of 6.02 times 10 to the 23 particles, otherwise known as 1 mole. It's the mass of 1 mole of particles. You will find the molar mass on the periodic table as atomic mass. For consistency's sake, we're going to round atomic mass to the nearest tenth, and you're going to try to get a minimum of 3 sig figs. So 3 sig figs. So if you round to the nearest tenth and you don't have 3 sig figs, let's say you have only 2 sig figs, then give yourself a 3rd sig fig by going to the hundredths place. The unit is grams per moles, right? Grams per moles. This is, and this, I'll write this, if we write it out, it's grams per moles. And as we know, G is the abbreviation for grams, and the abbreviation for moles is MOL. Okay, so we have to write that out as MOL as the abbreviation, not just M. M doesn't work because that's meters. So finding the molar mass of an element, we're going to go to the periodic table. We're going to go to helium. We see helium is to the nearest tenth. Let's see if we can get that focused. Nearest tenth is 4.0, but that gives us only 2 significant figures, so we're going to go 1 more digit beyond, and rounded is 4.00 grams per mole. Oxygen to the nearest tenth is 15.99939, 15.9994. So going to the nearest tenth, we have to round up. This is going to be 16.0 grams per mole. Notice that I am writing these as vertical fractions. I think this is a good idea for you to continue to write fractions vertically as opposed to in line. So this is what I don't want you to do. Okay, I want you to write them as very distinctly like a fraction. Okay. PB, if we take a look at PB, 207.2 is the molar mass for lead. Okay, so if you weigh out this amount of lead, you're going to have 6.02 times 10 to the 23rd atoms of lead. All right, let's take a look. What happens when you are finding the molar mass of something more than just a single atom? Well, you have to do a little scratch work. And you have to account for how many atoms there are. So, for example, hydrogen. There's only 1 element, right? But there are 2 hydrogens. So we're going to take 2 multiplied by the atomic mass, rounded to the nearest tenth, but giving ourselves 1 more significant figure. That'll be 1.01. Right? And so when we do, that's our scratch work, so this is going to be 2.02 grams per mole. Ki has 2 elements, K and I. So K and 1 of each. Potassium to the nearest tenth is 39.1. Okay, let's get more light there. 39.1 for potassium. 1 times 39.1. Iodine, there's also 1 of those. Iodine to the nearest tenth is 126.9. Okay, so adding that up, put a plus sign between there, we're going to get, let's see, 39.1 plus 126.9, and we are going to get 166.0, because our 2 measurements are each to the nearest tenth, so we need to honor that over here, and that unit will be grams per mole. H2O, we have a hydrogen and we have oxygen. We have 2 hydrogens, each at 1.01, and we know this because we saw that up above. Oxygen, there is 1 of them. Oxygen to the nearest tenth is 16.0. Adding those together, we are going to get 18.0 grams per mole. Okay, so notice that these had 2 digits after the decimal, but this one only had 1. So when we add numbers, we are only reporting our answer to the fewest digits after the decimal. Calcium chloride, we have calcium and we have chloride. We have 1 calcium, and we have 2 chlorines. So let's go look up their molar masses. Calcium to the nearest 10th is 40.1. Chlorine to the nearest 10th is 35.5. Adding up 40 and multiplying 35.5 times 2 plus 40.1, adding all that together, we get 111.1 grams per mole. Okay, 2 more to try here. They're getting a little more complex, a little more going on. This next one, we have carbon, hydrogen, and oxygen. We have 6 carbons, each at 12.0. We have 8 hydrogens, each at 1.01. And we have 7 oxygens, each at 16.0. We're going to add all that together. I'm going to run a little subtotal over here because there's a lot to manage. 12 times 6 is going to be 72. This is going to be 8.01. And then 16 times 7, 112.0. So I'm going to add those 3 numbers together. And I'm going to get 192.0 grams per mole. All right, last one, magnesium. I've got magnesium, I've got phosphorus, and I've got oxygen. Looks like I have 3 magnesiums, 2 phosphorus, and 8 oxygens. We know oxygen is 16.0. Phosphorus is 30.97, so that's going to be rounded 31.0. And magnesium to the nearest 10th is 24.3. So let's do the running subtotals on the side. 24.3 times 72.9 from all of the magnesium. We've got 62.0 coming from the phosphorus, and then 16 times 8 is 128. We want to add all those together. And let's see, 128 plus 62 plus 72. We are going to get 262.9 grams per mole. Okay, so if you are asked to find the molar mass of a substance, and molar mass being the mass of 6.02 times 10 to the 23 particles, to figure out how much mass you are going to weigh up, you are going to have to factor in the masses of all the elements that are in the formula, and you add them all up, abiding by significant figure rules to find what is known as the mass of 1 mole, commonly referred to as molar mass. All right, that's it for this part of the lesson. We'll see you back in the classroom.